Welcome to the first episode of our drone technology series. Today we're exploring the basic structure of a drone and the core principles of how it stays in the air. Welcome everyone. A drone is not just a simple flying toy. Inside its body, precise aerodynamic engineering and advanced electronic control systems work together. Understanding this structure is essential to control the drone safely during unexpected situations. And to maximize flight efficiency, today we will focus on the essential components and how they interact to create stable flight. First, let's look at the basic principle of how a drone gains lift. Drones use a rotary wing system similar to helicopters. Taking the most common quadcopter as an example, 4 rotating blades push air downward, generating thrust through action-reaction forces to lift off. To prevent the drone from spinning due to torque, 2 propellers rotate clockwise, while the other 2 rotate counterclockwise, balancing the physical forces. All directional controls such as ascending, descending, turning and moving forward are achieved by adjusting the real-time rotation, speed of each motor. This precise balancing act is managed automatically by the flight controller, the electronic control system inside the drone. Second, let's examine the main components and their specific functions. Every part of a drone is organically connected. The propellers are key elements that generate direct thrust by pushing air downward. To rotate these propellers at high speeds, brushless motors are used for their high efficiency and low wear. The electronic speed controller, or ESC, precisely regulates motor speeds to control flight direction and altitude. The frame acts as the sturdy skeleton holding all these parts together, usually made from lightweight, high-strength materials like carbon fiber. The brain of the drone is the flight controller, or FC, which processes all sensor data to maintain real-time flight stability. The inertial measurement unit, or IMU, includes gyroscopes and accelerometers to detect the drone's current orientation and fine movements. The GPS module receives precise satellite positioning data, enabling automated return to home and hovering capabilities. As an energy source, high energy density, lithium polymer batteries are primarily used to power all components. Finally, cameras for smooth, high-definition aerial footage are paired with gimbals that counteract multi-axis vibrations. Latest models like the DJI Air 3S or Mini 4 Pro feature highly modularized components that deliver powerful flight performance. Third, let's look closer at the detailed role of the flight controller. The drone's brain, the FC, stabilizes flight by processing sensor data hundreds of times per second and controlling motor output in real time. Even in strong wind, it automatically maintains level flight and balance. It interprets commands from the remote controller in real time to direct precise movements. Furthermore, it integrates data from GPS, IMU, and barometric altimeters to manage the overall flight. Specifically, DJI lineup uses advanced flight controllers with proprietary algorithms, helping even beginners fly with stability. Fourth, here is the sensor collaboration system that keeps the drone hovering without falling. Stable flight goes beyond staying airborne. It relies on maintaining active balance. To achieve this, various sensors continuously exchange real-time data. The IMU measures rotation, speed, and acceleration to adjust attitude, while the GPS provides precise position, locking, and automated return functions. Barometric sensors measure air pressure to maintain a steady altitude. In GPS-denied environments like indoors or under bridges, downward-facing vision sensors and LiDAR analyze surface patterns to accurately estimate position changes. International aviation guidelines and local flight safety regulations also emphasize proper sensor operation and pilot compliance for safe operations and registry. Fifth, why is it essential to understand drone structure clearly? Knowing the structure allows you to detect early warning signs like minor propeller cracks or sensor errors before takeoff. It helps you learn proper emergency procedures during sudden gusts or specific mechanical issues. Moreover, looking at the drone from a structural perspective helps you predict battery drain rates, motor heat, and signal loss to perform preventive maintenance. Ultimately, understanding drone architecture goes beyond theory. It secures flight safety, extends equipment lifespan, and increases aerial photography success rates. Let's summarize today's lesson. A modern drone is not a simple camera accessory, but a complete, highly integrated piece of aviation equipment. Taking off without understanding its mechanism is like driving a high-performance sports car without a license. Recognizing how the machine operates and how parts interact is the surest starting point for safe, confident flights. In the next episode, we will take a deep dive into the GPS system, how drones accurately detect their position, and return to the starting point without error. If you enjoyed this video, Please like, subscribe, and turn on notifications. See you on the next flight. Thank you.